Hello everyone and thank you for joining us in this EMWorks webinar. In this webinar, we shall show you how to simulate an MRI using EMS and HFWorks and try to answer the question of how safe is wearing a metal during an MRI scan. Our agenda is as follows: a brief discussion about our products and services, followed by the main technical presentation. After the technical presentation, we will brief you about licensing, services, and various learning resources offered by EMWorks. Then comes the questions and answers period. At that point, Dr. Kabir will go on stage and answer your questions. You may then type your questions in the chat section. All of your questions will be answered. All of our products are integrated into SolidWorks, the #1 3D CAD package. Some of our products are equally integrated in Autodesk Inventor. Why? There are a couple of reasons, including, we want to concentrate our effort on what we know best. Electromagnetic simulation. We don't want to reinvent the wheel. In other words, why should we develop a CAD while there are excellent professional CADs? Developing a CAD requires much more human and financial resources than a simulation software like ours. Indeed, all simulation companies that made the mistake of developing their own CAD ended up with a primitive and even mediocre software. Why bother about learning a new primitive CAD? Just use your professional CAD and start simulating right away. You can easily collaborate with other departments in your company since all of you use the same CAD model. Some companies that have their primitive CAD claim that you can import files from popular CADs such as SolidWorks or Inventor. It is true, you can import. However, oftentimes you would need to heal, stitch, or clean the geometry because of compatibility issues. Furthermore, if and when you need to make the smallest modification, you must start all over again. We hope that you understand now why we stayed away from developing our own CAD and, instead, relied on the professional CADs. We believe that we convinced you. You may ask now, what are the other companies that provide an electromagnetic software package that are fully integrated in a professional CAD such as SolidWorks or Inventor? Look no further. EMWorks is the first and the only company that provides electromagnetic software as add-in to SolidWorks and Inventor. As a matter of fact, the integration in SolidWorks dates back to 2007 and in Inventor to 2012. Consequently, we have more products integrated in SolidWorks which are all gold certified. Our products and services are as follows. EMS is a 3D electric and magnetic field modeling software for frequency ranging from DC to few hundred megahertz. It covers many applications like insulators, cables, bus bars, permanent magnets, actuators, circuit breakers, transformers, and motors. HFWorks is an electromagnetic simulation software for RF, microwave, high frequency, and high-speed electrical and electronic devices. It covers many applications including a wide range of antennas, resonators, filters, connectors, and waveguides. EMWorks 2D is a 2D and axisymmetric electric and magnetic field modeling software for frequency ranging from DC to few hundred megahertz. It covers the same applications as EMS. Motor Wizard is a template-based motor design software. It offers analytical and finite element analysis for BLDC and permanent magnet motors. In addition to these solvers, we offer several multi-physics modules including motion, stress analysis, thermal analysis, electric circuits, and ECAD. Let's move now to the feature technical presentation.
Welcome again to this EMWorks webinar. How safe is wearing a metal during an MRI scan? Magnetic resonance imaging or MRI is a powerful imaging technique to obtain detailed organs and tissues images throughout the body without the use of X-rays or the so-called ionizing radiation. Unlike X-ray and CT scan, MRI produces no ionizing radiation. Hence, there is no limit on the number of MRI scans a patient can have in a given year. However, it has another big limitation. It interacts with metals in two distinct ways. The first is related to the external large static field which generates a magnetic force on ferromagnetic materials. The second interaction with the metals is caused by the varying RF waves used in the MRI machines. If you had an MRI scan, the technician made you fill a form and sign it confirming that you are neither wearing any metal such as a gold ring nor have any metallic implement in your body such as a heart pacemaker. In addition, when you are about to enter the MRI machine, they probably asked you again the same questions about the metals. If you were an electromechanical engineer and wearing a gold ring, you might have argued with the technician that gold has no carbon and as such does not interact with static magnetic field. In this webinar, we shall explain to you why the technician insists on not having any metal whatsoever and not even a gold ring. Unlike the technician who instructed you without giving you convincing reasons, we shall use low and high frequency electromagnetic simulation to explain to you the technical reasons that satisfy your critical engineering minds. Our electromagnetic packages EMS, for low frequency, and HFWorks, for high frequency, along with SolidWorks are the main simulations tools used in this investigation. We shall start with EMS to study the effects of large static fields and how they interact with ferromagnetic materials. Since EMS is an add-in to SolidWorks, the number one 3D CAD software, the creation and modification of the geometry is as easy as a pie. As you may already know, an MRI is made of several coils and/or permanent magnets. In this MRI machine, only coils are used. The large external coil is responsible of producing a uniform static magnetic field. The gradient coil is responsible of producing a rotating magnetic field. In some MRI machines, the gradient coil is replaced by rotating magnets that achieve the same goal. The RF or birdcage coil is responsible on collecting the data and transmitting it to a receiving antenna connected to a computer where the radiologist reads the images. The human body phantom is made of muscle material that has the electrical and mechanical properties of an actual human tissue. Inside the phantom, we placed a small metallic rod of about 0.62 grams, close enough to a weight of a ring or other jewelry. We have two EMS studies. In the first one, the rod is made of a common ferromagnetic material steel 1010. Whereas, in the second study, the rod is made of gold. We shall compare the force acting on the rod in both cases. Let's examine the results of the steel study in some details and then compare the results with the gold study later. After the run is complete, results folder is created and contains different type of results. Double-click on results table to examine lump circuit and mechanical quantities as well as motion results, including force, torque, resistance, current, and energy for each time step or each motion position. All of the results table quantities are plottable as function of time or position. For example, click on the FX force component and click Add in the parameters field. Click on Pop-up Plot. The plot of FX versus time appears. You can track it, smooth it, print it and export it. You may equally view the listing by clicking on its icon as shown, which you can save in different formats. Follow the same steps to plot any of the table quantities. To plot the motion parameters, click Plot at the bottom of the table as shown. It shows the center of mass of the moving bodies as function of time. In this case, the metallic body would move around 4 mm in 0.6 millisecond. If we were to extend the simulation time, the metallic body would eventually move out of the MRI machine altogether. You may also plot the velocity and acceleration, as shown. To close the results table, click Close. The magnetic flux density and magnetic field folders contain the near flux density and magnetic fields in the entire model. From the magnetic flux density folder, we can create different types of plots: fringe, vector, streamline and 2D plot. Right-click on the magnetic flux density folder and choose 3D fringe plot, no clipping. The magnitude of the magnetic flux density is color-coded, where the red color is the maximum and the blue color is the minimum, as shown on the legend on the right side of the plot. Click on different time step. The values change. Click OK. Right-click on the plot icon and animate, as shown. Right-click on the magnetic flux density folder and choose 3D fringe plot section clipping. Check plot on section only. Click OK. Right-click on the section plot and animate versus time. Right-click on the section plot again and animate versus section cut this time. Right-click on the magnetic flux density folder and choose 3D vector plot, no clipping. Click OK. Right-click on the vector plot icon and animate, as shown. Right-click on the magnetic flux density folder and choose 2D plot linear. In the graphic area, click on several points on the model, as shown. The magnetic flux density plot between segments appears. All the plot performed on the flux density can equally be applied on the magnetic field, applied current density, and force density. Last but not least, you may generate a report that summarizes all of your work. Right-click on Reports folder and generate. Customize your report and choose either HTML or Words format. Click OK. Let's now compare the results from different studies. From the root of the tree, choose Compare Results Motion Studies Magnetostatic. Click on the FX force component and click Add in the Parameters field. Click on Pop-up Plot. The plot of Fx versus time appears. Clearly, the magnetic force acting on the small metallic part reaches around 26 newtons for the steel material and around 0 for the gold material. Practically, what does it mean? Well, it means that the small steel part would fly out of the MRI machine and probably hit someone, whereas the gold part would not move at all. Does it mean that the MRI technician is right about the steel part and wrong about the gold part? To answer this question, we must use HFWorks to investigate the high-frequency aspects of this question, since the birdcage coil uses RF energy. Similar to EMS, HFWorks is fully integrated in SolidWorks. The same model is used again and two studies are created too. One using gold and the other using steel 1010 for the metallic piece inserted in the human body phantom. To study the frequency response of the RF birdcage coil, the S parameters module of HFWorks is used. Let's examine the gold study in some details and then compare the results against the steel study. Right-click on the gold study and choose Properties. Click on the Frequency Sweep tab. It is fast sweep from 60 to 70 MHz with 51 frequency points. Click on the Coupling Analysis tab. Note the thermal coupling is checked. Click OK. The material for the metallic rod is gold, whereas all coils are made of copper. The human body phantom is made of ASTM phantom with properties very close to actual human muscle. Since the RF coil is inside the MRI machine, lumped elements and lumped ports are used to excite it. After the run is complete, Results folder is created and contains different type of results. Circuit Parameters folder contains the results table and 2D plots. Electric field and magnetic field folders contain the near electric and magnetic fields in the entire model. Port fields folder contains the electric and magnetic fields on the ports. Loss density and total loss folders contain the volume and surface losses inside the structure. Double-click on the results table. It contains all circuit parameters for all frequencies. Click OK. Right-click on the Plots folder and add a new 2D plot. Choose S11 from Parameters and click Add. Choose S12 from Parameters and click Add. Click OK. The plots of S11 and S12 versus frequency appear. Clearly the RF coil is well matched. From the electric field folder, we can create different types of plots: fringe, vector, or streamline. To show the fringe plot of the electric field, right-click and choose Fringe. Excite port 1 and port 2 with 300 watt power. The magnitude of the electric field is color-coded, where the red color is the maximum and the blue color is the minimum, as shown on the legend on the right side of the plot. Click OK. Similarly, you can plot the magnetic field, the port fields, and the loss densities. The above electric parameters and field plots are important to properly design the RF coil. However, they don't tell us much about the safety issue that we are trying to answer. It is the temperature in the metallic piece and its surroundings that can. Fortunately, HFWorks has an integrated thermal solver for both steady state and transient. Hence you will never need to export the data to a separate thermal software. To examine the thermal study properties, right-click on the 300 watts thermal study. As you can see, at each port 300 watt is applied. The dielectric and conductor losses are checked. Click OK. All thermal loads due to dielectric and conductor losses are automatically applied to the thermal program. You just need to apply the convection boundary condition in the air region. Right-click on the 300 watt study and choose Run. Right-click on the temperature folder and add a new plot. Check Show Plot only on selected entities and choose the metallic rod, as shown. Clearly, a temperature around 64 degrees Celsius is reached. Oops! It is hot. A 64 degrees Celsius definitely burns the human tissue. Upon examining the steel study, for the same 300 watts applied power, the maximum temperature in the rod is around 38 degrees Celsius. It does not burn. However, at 600 watts applied power, the maximum temperature is around 109 degrees Celsius, which is definitely a burning temperature. Well, the MRI technician is right. Even though the large static magnetic field does not exercise any force on the gold part, the RF power induces RF current in the metallic part, causing it to heat up to a temperature that burns the human tissue. As for the steel part, it interacts both with the static magnetic field and the RF wave. It can move or even fly under a static magnetic field and heats up under an RF field, though less than gold. Why? Well, because steel has a high magnetic permeability and a high electric conductivity, whereas the gold has a permeability of air and very high electric conductivity. To conclude, it is not safe to wear a metal during an MRI scan, not even gold. Thank you for attending this webinar and hope to see you in future webinars.
Thank you everyone for bearing with us, and I hope that you have learned from the feature technical presentation. Let me briefly touch upon the licensing structure offered by EMWorks. We offer 3 different programs: commercial, academic, and startup programs. Each program has its own benefits and requirements. For the commercial program, we offer perpetual licenses. Our licensing structure is usually annual based for the rest of the programs. We have a combination of free and paid licenses for students, academics, mentors, lecturers, and professors based on the program they choose. For startups, we offer a very interesting and generous program that saves you money for other startup expenditures. Learning resources. EMWorks offers you various free learning resources. a standard help and step-by-step tutorials, a demo viewer that gives you a head start by accessing many predefined examples and tutorials, regular webinar series on trending electromagnetic topics. Like today's webinar, we regularly post several application notes, blogs, and videos on our web page and social media channels. An annual user conference where you can exchange views and experience with other fellow users. Paid and free web and in-person training. Monthly newsletter to update you about the latest releases, webinars, and other activities. Support and services. Our support service is the strongest point that I can mention in this presentation. We always have your back before and after sales. We offer one-to-one web demo sessions to give you a head start and shorten your learning curve. You may even run a benchmark for you if you want to skip the trial option. We offer consulting and design engineering services. We may even propose to you a new design as per your requirement or refine and optimize your existing design. Featured customers. These are just few of our respected clients. These big names, that come from various industries, are true testimonial for the quality of our products and services. I encourage every one of you to try our software and experience its power and ease of use. We offer 2 weeks of free trial license. You may opt for a benchmark instead of a trial license. Please visit our webpage at www.emworks.com. Go to our Contact Us page. Fill in your information and submit your request. We will contact you promptly. On behalf of EMWorks, I would like to thank you all of you for attending this webinar. Feel free to contact us after this webinar to get more information on our products. Now we pass to the questions and answers period. Please type your question in the chat section on the right of the screen. I kindly request Dr. Kabir to go on stage and answer the questions.